Good morning. My name is Jeff Allen. I'm Executive Director of Fourth. And I'd like to welcome everyone to this virtual roadmap panel, Charging Heavy-Duty Electric Vehicles. I'd like to note, and we'll note this a couple of times to remind folks, that we will be sending out a recap of the series at the end of the week tomorrow. And that will include all the slides that are presented and some additional information and the recording of this session. So if you missed something, never fear, you will have a chance to watch it in reruns. Before we get into the panel today, I'd like to take a moment to recognize the obvious, which is that this is a remarkable time. Obviously, we're in the midst of the global COVID-19 pandemic that's disrupted our lives, but we're also in the midst of confronting a pandemic of racism in this country that's been disrupting and ending the lives of people of color for generations. We've been reminded of this with the recent murders of George Floyd, Ahmaud Arbery, and Breonna Taylor. But I think we all need to be reflecting, I know we at Fourth are reflecting on the need to double down on our work to center equity in our lives and in our professional work. And in that regard, I think today's topic is quite timely. It's been obvious for a long time that communities of color are most heavily impacted by air pollution from traffic and from heavy trucks and industry. COVID has made that institutional racism much more immediate and clear, as communities of color have been contracting and dying from COVID at rates up to 5 times higher than whites. So I'm very pleased to have a panel today that will talk about how we can accelerate the use of zero emission vehicles to reduce that pollution burden. As Fourth said in our statement of solidarity recently, we have a responsibility to explore how our industry can better serve and support communities of color. And I'd like to think this will be one small contribution. For those of you who may not be familiar with Fourth, we're a nonprofit trade association and advocate for electric and smart transportation. We have over 180 members, ranging from automakers and charging companies to consulting firms, governments, NGOs, and really the entire ecosystem. In addition to hosting the Roadmap Conference every year, we create and manage demonstration projects, we advise state and local policymakers, and we run, in a normal year, one of the largest consumer engagement programs in the country, including dozens of ride and drive events and a storefront showroom. Normally, we would be bringing you all here to Portland and welcoming you to some beautiful sunny weather this week. And we were very excited to be doing that this week because it would have been in conjunction with the International Electric Vehicle Symposium, which would have brought a couple of thousand additional international industry leaders to Portland. Unfortunately, for obvious reasons, we had to cancel that and pivot to presenting these panels as webinars. But we're very glad you could join us for this. And I'm extremely happy to say that we have already locked in dates for Roadmap 2021, which will be June 29th to 30th next year. And we look forward to welcoming you to Portland then. Registration is in fact already open, and we're offering a generous pre-sale discount through the end of the year. We're also offering discounts to sponsors for Roadmap through the end of the year. So many of you have come to Roadmap, mark it on your calendar every year. I would encourage you to do that soon and show your support and your intention to join us. I'd also be remiss if I didn't mention that members of Fourth get a substantial discount on registration and sponsorship, which also leads me to point out that if you are not yet a member of Fourth, this would be an excellent time to join. We will be including membership information in the webinar recap that goes out, or you can just visit fourthmobility.org for more information about that. During each of our panels this week, we're also presenting the second annual Roadmap Awards. And today I'm happy to be presenting the Private Sector Leadership Award, which honors an individual or an organization exemplifying private sector leadership in smart transportation. And I'm particularly proud to be presenting the Private Sector Leadership Award today to a neighbor company of ours here in Portland, Daimler Trucks North America. We're recognizing Daimler Trucks North America for introducing the world's first autonomous commercial vehicle licensed for use on U.S. public roads, for their commitment to ensuring cleaner air to children who ride school buses through their Thomas-built bus subsidiary, and their electrification of their heavy-duty trucks as well. We applaud their leadership in the change towards zero-emission heavy and medium-duty trucks and school buses. And we're very happy to have John O'Leary, the CFO of Daimler Trucks North America, here with us today to accept the Private Sector Leadership Award. John, would you like to say a few words?
I would. I just have to turn on my webcam. Jeff, thanks so much for those kind words and recognition for what we've tried to do. I'm honored to accept this great-looking award on behalf of the entire team at Daimler Trucks North America. It's really a unique and great-looking award. I've already had a few people come by my office and, of course, from the proper distance, observe this, and they're saying, wow, that's really cool. So thank you. That's going to look great in our corporate trophy case. Our shared future really depends on the collaboration of public-private enterprise to quickly accelerate the deployment of CO2 neutral commercial transportation. We're proud to lead the way with vehicle development right here in Oregon. So again, thanks so much, Jeff, you and Forth, for all you do, especially our partners that we work with very closely, PGE and TriMet, on this particular project. And again, thanks for everything today, and I'll kick it back to you.
Thank you very much, John. One more thing before we get into the substance of today's panel. We could not present all of this wonderful content and all of these events and share it with you for free without our sponsors. And I want to recognize our sponsor today, ABB, a longtime member and generous supporter of Forth. And we have with us today Kendall Whitehead, Heavy Vehicle Charging Solutions Sales from the Western Region, representing ABB. And Kendall, I'd invite you to say a few words as well.
Yeah, absolutely. Thank you so much, Jeff, for the introduction there. Hey guys, thanks for joining us today. Yeah, Jeff kind of gave the quick introduction on me. I'm the Heavy Vehicle Charging Solution Sales Lead for the western half of the U.S. So my evolution into that role kind of started with a lot of different work in new product introduction, particularly in the heavy vehicle solutions market. And so I've got a kind of a vested interest in this webinar myself. I really enjoy the topic area, and so I'm super excited to hear what everyone's got to say today. I'm also based out of Portland, so I'm very familiar with Forth and some of the other partners in that area that we've got. So working with them is always really fun, and this new technology is always really a fun challenge as well. So ABB is a really proud sponsor of Forth. We're really proud to be a member of Forth. We've been supporting Forth in the Roadmap Conference for several years now, as Jeff said. And I think everyone's going to say this, but it's such a bummer that we can't all be together at the Oregon Convention Center for what's normally one of the best EV conferences you can attend. I've been for the last several years, and so there's a little bit piece of my heart missing right now from not being able to attend the conference. It's really one of the best, and if you're not going normally, I really suggest that you add that to your calendar every year. So just a quick overview on ABB for those that don't know. We're a global leader in power and automation technologies. You can find our products in all sorts of markets, ranging from traditional industrial plants and manufacturing facilities, high-tech robotic facilities, data centers, and of course, electric vehicle fleets, public charging stations, and that type of thing. Our mission at ABB is reaching that kind of zero emission reality. We know that transportation emissions are 24% of global CO2 emissions, and that value is only going to grow if we don't do anything to curb it, right? We all know this. That's what we're here for. So I'm preaching to the choir, but anyways, we've got to continue to work on this, and that's kind of ABB's vision here. Because electric vehicles emit 54% fewer CO2 emissions than ICE vehicles, we see the electric vehicle industry, the infrastructure industry, as a particularly impactful market for reaching the zero emission world. So we're heavily investing in that market. As I said before, we've been heavily committed to the EV infrastructure world for some time now. We've got an install base of more than 14,000 DC fast chargers across the globe, over 2,000 in North America. We see that the heavy duty market is particularly poised for growth. This is bus and transit, and then the truck market as well. And so we're creating solutions to fill the needs of those markets. You can see some of those solutions here. We've got overhead pantographs, we've got plug-in solutions, depot style solutions that we're working with a lot of our transit agencies on, and really trying to get creative with fleets and trucks as well. I think I even took a few of these photos myself after a long day of work, commissioning and installing and doing interoperability testing. So it's really cool to be able to see that and show that to you guys here in some of these photos. Again, I want to thank you all, and particularly Forth, for the opportunity to sponsor this webinar. I know that we've got some great speakers lined up today that are going to give us some of that juicy insight on the heavy-duty EV world. And again, that's my space. So I'm really excited to hear what all is going to be talked about today. And with that, I'll hand it back over to you, Jeff. Thank you again.
Thank you, Kendall. Really appreciate your support and the shout out for Roadmap. So with that, let's get into the substance of today's conversation. And to take us there, I am thrilled to have another longtime friend and supporter of Forth, Commissioner Patty Monahan of the California Energy Commission. Patty, take it away.
Thanks, Jeff. Well, it's really a pleasure to be here today greeting everybody and kicking off this session on heavy-duty electrification. I also want to give a shout out for the Forth Roadmap Conference. If you haven't been, come. It really is the best electric vehicle conference. I think, I mean, in the U.S. and maybe globally. I've been to several globally as well, and I got to say, the Forth and the team at Forth does a great job of putting on a conference that brings together diverse stakeholders, all united with the goal of trying to electrify transportation as rapidly as possible to address the climate crisis. In California, we're motivated doubly because of our air quality. We have two air districts with the worst air quality in the country. The reason California has a unique authority to set vehicle standards is because of our air quality, and we've been exercising that authority for 40 years plus. The sector that we, I think, are focused, I mean, we're focused on light-duty electrification, but also heavy-duty electrification in California in order to bring down harmful diesel pollutants and address NOx emissions that cause smog to form. And as Jeff said, this sector is particularly interesting because if there is a business case for investing in electric vehicles, we could see scale happening more rapidly. And we are at the very early days of that transition, but I think we all have a lot of optimism that we can move forward quickly once we overcome some key barriers for electrification. I like to say there's these three barriers that we're trying to overcome: cost, convenience, and consumer awareness. In the heavy-duty space, I think cost and convenience are the two that we are most focused on addressing. And this panel is going to talk about a collaboration that's happening in real time in Southern California with Daimler Trucks, Penske Transportation Solutions, and Southern California Edison. And we really need, I think, this partnership between these stakeholders and others to be able to overcome the barriers for cost and convenience. And when I say convenience, I mean a convenient refueling infrastructure. And I can't emphasize enough the importance of integrating heavy-duty vehicles into the grid in a way that supports our goals for the electricity sector. If vehicles are charged at the right time of day and in the right ways, they actually provide a benefit to the grid and a benefit to all electricity users. If they're charged in the wrong way and the wrong time of day, it causes an increase in peak demand and some challenges for us as we try to decarbonize the grid. So I want to introduce the panel and dive right into the discussion because they're the ones that are on the ground trying to make this collaboration successful. So we have three panelists, Nate Hill, who's the head of charging infrastructure at Daimler Trucks North America. He's part of the team that uses Daimler tools to help customers bring power to the truck in a cost-optimized way. We also have Sean Yentsch, who is the Director of Facilities at Penske Transportation Solutions. And in his role, he's responsible for capital planning, engineering, site selection, and construction of the charging infrastructure. Finally, we have Simon Horton, who is a Senior Project Manager at SoCal Edison, and he's the lead project manager for the assessment, design, and construction of all the utility EV infrastructure programs. So really excited to have this conversation, and why don't we dive in, and I turn the mic over to over to Nate.
All right, thank you, Patty. Thank you, Jeff, and a huge thank you to Fourth Mobility for this opportunity to speak to everyone about charging infrastructure. My name is Nate Hill, and I lead the charging infrastructure team at Daimler Trucks North America. Okay, I've tried to advance the slide, and here we go. Okay, so we at Daimler are very proud of the part that we're playing in this revolution. We're very proud of our friends, our colleagues at Thomas Bell Bus and everything that they are doing there to electrify school buses. The Julie product has been delivered now to the first customers and is performing well. And I think probably the best named product out there, Julie. I love that name. Also, we've made big announcements, and some of these you've seen, deploying Class 8 and Class 6 vehicles and pilot projects down in Southern California. We've made major statements about the future being electric in the truck industry. These are bold statements, and we intend to back them up. Today, I want to talk to you more about some of the experiences we've learned through this process. What is the motivation for battery electric fleets? Certainly, there's environmental factors. For years, Daimler has done so much to reduce the pollution from our diesel vehicles, and now it's time to take it to the next level. Battery electric and hydrogen are part of that equation, and we intend to do everything that we can to improve our impact on the environment in a way that is sustainable, both to the environment and for our customers from a business perspective. Cost of ownership is a huge driver for us. Anyone in the industry knows and recognizes that this is not a cheap technology on the infrastructure side or the vehicle side, but where it's headed is very exciting. And over the next years, over the next decades, we see the cost coming down significantly, and we're working towards that, both on the vehicle side, but then working with partners and with utilities to see what can be done on the infrastructure side as well. Policy and regulations. Across the country, new regulations are coming out. We want to be supportive of those where they make sense and work with legislators to implement these policies and regulations that are good for the industry as a whole, as well as the environment. We've done a lot to lead the charge. We've done much to gain knowledge and push the technology forward. I was proud to be part of a small team that pushed out the first electric prototype, eCascadia and EM2. From there, we've grown significantly. And thanks to funding from South Coast Air Quality Management District, we are able to deploy 20 vehicles down in Southern California. These vehicles are part of our electric innovation fleet. I'll talk more about that in a few slides. We've also announced recently the deployment of a customer experience fleet, which is 8 additional vehicles being deployed in parts of California as well. And we're moving towards a series production of our eCascadia and EM2. In the next couple of years, you will see series production Freightliner trucks on the road. We're very excited about that. But the deployment, I'm on it. The deployment of e-trucks takes a lot more than what we are used to as an OEM. Traditionally, we focus mainly on the vehicle. Now it's time to go beyond that. We have to look at charging infrastructure. We're looking more at regulations and incentives. And we have to take a deeper look at our customer use cases, because the particulars of a customer's use case dictates whether or not in the near term an electric truck can meet those needs. And so we're working very closely with customers on that. As we take a look at the entire ecosystem, one stands out in there with particular challenges: charging infrastructure and deployment of that infrastructure in preparation for deployment of the trucks. We have to take a look at this early. We have to take a look at the cost. We have to plan early. As we take a deeper dive into this, we can see the complexity of this topic. Site evaluation and planning, charging equipment selection and installation, site construction, grid connection, rate schedule selection and negotiations, maintenance and operation of this equipment. How do we manage the energy? What tools are available to manage the energy and optimize cost through this? We have to look at not only private deployment of this infrastructure, but also public charging in the future. To do this within Daimler Trucks North America, we've started a team, the charging infrastructure team. A small team for now, but we are growing. There's lots of topics. As you can see, each topic is covered by individuals on our team. We also work individually with our customers to help them go through the path. We help them understand what it takes to deploy, which partners they should be working with at each step, and how to make what could be a very rough experience a little bit smoother. It's never perfect. There's always surprises, and we'll talk a little bit about that in a couple of slides. The other thing we're working on is standardization. Our first trucks will use the CCS1 charging standard. We believe that to be the leading standard, the standard chosen by most OEMs in the US right now, and that's what we will deploy with. As we look forward into the future, we recognize that CCS1 standard has limitations. And so as we planned for not just 5 years into the future, but 10, 20, and 30 years into the future, we recognize a new standard will need to be developed. To that end, we have led a person on my team, Rustam Kocher, is leading a task force through the Charin organization to develop and define a new standard with higher power requirements, new standards for communication. It's a long process, but we believe that we need to work with the entire industry to push towards that new standard to make electric trucks a reality in not just fringe cases, but in many, many cases. Lots of challenges arise with this new standard. Many in the industry are involved in the standardization and defining that standard, and we extend a big thank you to everyone who has put time and resources into helping define that standard. As we go to a new standard, there will be a transition from the old standard to the new, and it will be difficult to manage that for OEMs and for charging manufacturers. At Daimler, we're coming up with strategies to make sure that the transition to a new standard in the future will be as seamless as possible. It will be challenging, but we have some strategies to address that, and we're working with EVSE manufacturers as well on those strategies. I want to talk about the innovation fleet. This has been a great experience for us. These 20 vehicles, which are all operating now in Southern California in real-world applications, actually on revenue-generating routes, has been such a valuable experience for us and for our partners. From the infrastructure side, this is not an easy thing to support. We have 8 sites, 20 chargers, and 30 dispensers that were deployed in support of this electric innovation fleet. And you can see here just by the icons on this slide, it takes a ton of people all cooperating very closely together. We'd like to thank again South Coast Air Quality Management District for providing much of the funding needed for this project. I think it's been very successful to this point. We continue to work with them. Huge thank you to our customers, Penske and NFI, and to all of our partners on the project for making this happen. Super happy to be on the panel with Sean Yentsch from Penske and with Simon Horton from Southern California Edison, who have been instrumental in making this project a success. I want to share some of the lessons that we've learned from this, and this is just a few of them. I got 3 slides on this. As I already pointed out, many parties will be involved. It's important to find a good general manager for these projects. It's important to get recommendations. A lot of the partners that our customers and others will have when they're deploying infrastructure are names that they're not familiar with. So seek out recommendations, talk to others about their experience, and try to find the right partners early on. It's important to invest in resources, dedicated team members, and planning. And in the planning process early on, this can save a lot of time and cost later. Lesson number 2, charging infrastructure costs a lot of money. Because of this, it's very important that you don't just buy equipment that works for you, but that is properly sized. Typically, you want to go smaller equipment and spread out your charge time if your applications allow for this. We want to minimize the number of chargers that we need. In many cases, you do not need 1 charger per vehicle, but we can reduce that. In some cases with our customers, we have plans to support up to 5 or 6 vehicles off of a single charger. If your operations allow for that, you can save a lot of money that way. Incentives are important. This is expensive, but because of that, there are grants available. Charge Ready program from Southern California Edison plays a huge role in making this work financially from a customer's perspective in the early years, as well as the LCFS credits in California in particular. Those are also helping mitigate the cost of providing electricity to these vehicles. On top of that, we're working with EVSE manufacturers to drive down the cost of equipment, just like we are doing on the vehicle side. Huge efforts need to be made there on infrastructure side and the vehicle side. Lesson number 3, plan for delays. Lead times can be very long for chargers, for the transformers, for switch gears. In general, if you're planning for a decent sized deployment, maybe 5, maybe 10, maybe more vehicles, plan on anywhere from 6 to 18 months to deploy that. Permits can slow things down. Environmental impact reports can slow things down. All of this slows things down. Our vehicles won't be coming to market for another couple of years, but that means now is the time to plan for the infrastructure. Lesson number 4, manage the load to hit your target and TCOs. There is software available for chargers that will help you manage that charge time so that you're not just plugging in and charging right away. Using the software, you can avoid high time of use rates. You can minimize peak power, and software can help you do that in a way that doesn't drive your fleet managers absolutely bonkers. Lesson number 5, things break. Everyone who's used a charger in the public has seen broken chargers, broken connectors, broken cables. This is a reality. For our customers, we've learned that having a service level agreement with an EVSE manufacturer or other providers of maintenance for chargers can help. You want to have a quick turnaround. You want to have spare parts if you can, or redundant chargers. These are all things that we speak to our customers about and help them come up with a plan for. And they're helping us learn too. Lesson number 6, compatibility is not guaranteed. If the plug fits in your vehicle, it does not mean that it will charge. And this is very, very, very true, especially as we push the limits of what the CCS1 standard was intended to provide. Voltage and communication protocols matter. Every EV must be checked with every model EVSE. So to that end, we work with EVSE manufacturers to test our Freightliner product on each of their models. And in the future are planning for test facilities that allow us to do that in a more managed process. So these are just some of the lessons that we've learned. I know I've taken up maybe a little bit too much time, so I want to pass the mic over. Thank you very much.
Great, thanks, Nate. So let's pass the mic over to Sean Yentsch, the Director of Facilities at Penske Transportation Solutions.
Great, good morning, everybody. And much of what we'll cover today a lot you'll see overlaps with what Nate was just talking about. So we'll pick up a little time here to give everybody time at the end. But really appreciate the opportunity today to talk about our commercial EV program, specifically the heavy-duty charging equipment, what we did across our 6 different locations, what we did right, what we did wrong, and what we continue to learn through this effort. It's an ever-evolving space. So I thought I'd just start off with, again, a brief overview for those of you that don't know Penske Transportation Solutions. We're a transportation solution in many forms of rental, leasing, maintenance, and logistics services. This is our 50th year in business. We've celebrated that this year with over 15,000 customers and over 300,000 vehicles in our fleet. So you can really truly say we are a fleet of fleets for our customers. Our customers look at us as a trusted advisor in all their transportation matters. So our fleet electrification efforts really fit right into the evaluation and implementation of these technologies and how we come to understand what our customer needs are and how to meet those for their business. So just kind of reiterating a little bit of what Nate touched upon, it takes a really great team of partners to pull off an effort like we've done this past year to year and a half, deploying the 20 medium and heavy duty vehicles around 6 different locations in the Southern Cal Edison area. Of course, Daimler Trucks North America, again, thank you, Nate, was our primary partner, but we also picked up several others along the way. Southern California Edison was a tremendous support from the utility side, and we had a great construction lead with Beard Electric and Opti that did a lot of the heavy lifting once we got to the construction set. A lot of our regulatory partners, South Coast Air Quality Management District and EPA, also the ports of LA, Long Beach, provided over $16 million in grants to help fund the deployment and support of these vehicles, so much appreciated. And again, it's a partnership when you go through something like this. I just want to take a little bit of time and kind of walk you through, what we kind of emulated around our 6th site and what that standard kind of evolved into. So this is really a prototypical charging infrastructure that we did. This is set up to charge 4 vehicles. Really had to kind of invent ourselves because there wasn't a lot of good heavy-duty commercial examples out in the United States. Europe has a few out there, but from what we found, we really had to kind of start thinking about what this was going to look like without any base or knowledge to really go on. So again, we looked at what we needed for a power standpoint. So 480 is typical. You'll see across what the industry is putting out there. And as you can see in this kind of setup, just kind of walking through for those of you that aren't familiar, cable management is a huge part of the system. Again, nothing's out there commercially that really goes with a 20-foot, 30-pound cable. So we've really pirated this off of a fuel diesel system. And it's really just a hose bun, but you have to keep that length and that weight and everything off the asphalt for protection damage and so on. Most of you will probably see when you put up in the setup, we chose a 150 kW charger. So you'll have a cabinet that supports your charging networks. For this system, the ABB, we had 2 depots per charger. So you can see we replicated the system down through in a fashion that worked for us. You also see a main distribution panel, very critical to the operation. You'll find that with the special EV rates out there that exist with utility, having a separate meter set up for your EV infrastructure is very beneficial in the long run, and it allows for easier construction and installation rather than trying to tap off your building and the positioning of where you want to, engage your system on the lot. And then lastly, you can see the monitoring and communication panel. So again, very critical So what you'll find in some of the EV setups and where the future of this is going is having that ability to remote dial in and out for software communications, uploads, and just general third-party software where you're going to be monitoring your load. And to Nate's point, where you can dictate through that software how you want to run your charging and what times a day. So this is just 4 examples of 6 of the locations we have up and running. You'll see up in Chino and then obviously in San Diego, we use the ABB equipment there for our test run. In La Mirada in Anaheim, we chose BTC that was local to run their equipment through as first testing. And this theoretically gives us about 14 stations that we can charge at one time through those 4 locations from 0 to 100. We planned on for the EM2s for the project, from 0 to 100, we figured about 3 hours of charge time. And for the E-Cascadias, the larger heavy duties, from a 0 to 100 state of charge, we could do it in about 4 hours. So throughout these charging sessions, to Nate's, kind of thought what Nate said in the program here, a lot of the trucks are coming back real time. They're not actually at 0. So they might come back at 30, 40%. So that charge time is a lot faster than our design time that we've seen out there. So the state of charge at 30%, we might now be able to charge that truck in an hour and a half to 2 hours max, which is very beneficial, especially on the intercity runs. So in Ontario, this is one of our larger sites. Actually, is our largest site. And for this site, obviously, we used Fluence for a battery energy storage system. And we also chose Siemens for the equipment here to try to give us a diversity of equipment that we could run through the pilot program with Nate's team and also our experiences. Ultimately, we'll begin testing for the resiliency and the peak shaving opportunities through the battery. We're still working through some of the software and the microgrid on that, but we're very excited to kind of see where that leads us down the road. So just a couple things, lessons learned, and we've talked about this a little bit today in Nate's presentation, and last year at the ACT we kind of touched upon this, but you know, this stuff is all new. So a lot of people are really excited about heavy-duty commercial trucks, but you just can't walk into a dealership today and pick one of these things up and drive it home. So there's going to be a time you have to be patient, and a lot of this is being kind of invented and designed on the fly, and that really had a big impact of what we did. You know, as the public charging stations grow out there across the United States, currently you can't find a place to pull in an E-Cascadia or a 53-foot trailer or even a straight truck. So, you know, finding dedicated design solutions is really got to be a key in the future. Obviously, utility partner, very key on this. Simon's team was instrumental in getting our timelines down very tight. I think we exceeded all our timelines by weeks to, if not months, just by having the right design and doing it very quickly. And again, to Nate's point, engaging early and often is really the key to getting this done. Layout, just things to think about when you're looking at your business, your site, or questions that we came up with internally, but you have to have room on your lot, and you have to really come up with designs that you can adapt to parking. A lot of this has to be perimeter. You have to worry about your cable management, which is really adaptive to the truck location and the OEMs because of the stress on that. And then really, I think the future is going to be more of a drive-through nature as the dispensers get faster at charging the trucks and the battery technology gets better. So you'll almost be like a traditional fuel island, I think, is where you're going to see this go. Communication is really big. We found a lot of things with the communication between the charger and the truck could be off a millisecond. It might be due to a cable length, a software, transformer within the dispenser. All of that is very critical to get this system to operate correctly. And then lastly, you have to be, all these solutions that we're playing with today and you're seeing in the future, you'll have to have something that's very feasible with standards. So we are coming away with a lot of great project ideas, working with CHAR, as Nate had said, and really trying to standardize, whether it's software, equipment, feedback to the manufacturers, and so on. And lastly, again, Nate touched on it, this stuff is really expensive. It's not cheap. It takes a lot to get an ROI, and you need those grants, incentives, work with the utility companies, carb credits, and other government incentives to really make this stuff move forward until we get to a point where, it's an everyday thing. So with that, I'd like to just say thank you to everybody with the partnership with Daimler, the South Coast Air Quality Management District, Southern Cal Edison, and thanks for your time today.
Great, thank you. So now I turn, the next speaker is Simon Horton from Southern California Edison.
Great, thanks, Patty. Appreciate it. And thank you for everyone here, and really thank you to Forth for putting this together. I'd like to spend most of my presentation kind of bringing full circle what both Nate and Sean mentioned, digging into a little bit of what we did to support the Penske projects and some of the best practices that we learned through that process. Important thing that Nate mentioned right out of the gate, and then Sean mentioned it also, is just the cost of this. And Southern California Edison, through our Charge Ready Transport program, is really trying to help reduce that initial cost barrier by providing infrastructure for fleet electrification. And this is a program that we launched last year. It's got a total program budget of $356 million. Our goal with this program is to get into a minimum of 870 sites and help provide the infrastructure that would electrify close to 8,500 vehicles throughout our service territory. That program does cover the cost of all the infrastructure needed up to the charging station, so both the utility side and the customer side infrastructure. And then there are rebates available for certain market segments. And you can see there at the bottom of the slide just kind of a timeline. If you add all of that up between the application all the way out to the design and build and the final rebate portion, you're easily at that 1 year. I saw both Nate and Sean mention time, and the reality is when you're building one of these big projects from inception to completion, you really do need to start thinking about that 1 year plus timeline, 18 months. The important takeaway here, and I'll return to this pretty much on every slide. The important takeaway is utility early so that we can be your partner. Just a little bit more description of the way our Charge Ready programs work. You can see in that illustration there, there's that gray dashed line, and everything to the left of that's the typical utility portion of a project, the transformer and the service to the meter. Everything beyond that's typically what a customer has to build, and in this medium and heavy duty charging infrastructure, that's very expensive. And so with our Charge Ready programs, Southern California Edison takes on the burden of the design, permitting, and build of all of that infrastructure. And the customer's obligation then is procuring the actual EVSE charging stations and installing those at the make-ready position that Edison provides. For customers that don't want to proceed through our Charge Ready Transport program for one reason or another, if it doesn't meet with their program guidelines, timelines, or they're deploying, it was mentioned a couple of times here, the standardization. We with our Charge Ready programs, we enforce standardization of plug interface. But for projects that want to proceed outside of a program like that, Edison does offer our commercial EV infrastructure process. So these are regular customer-driven projects. And I won't go into all the details in the slide there. You'll be able to see it when the slide show is shared after the meeting. But I do want to illustrate that SCE and many of the other utilities across the country have come up with very structured design and implementation timelines, so that as a customer moves through the process, it's a very defined process with easy to follow steps, and it's easy to figure out where you are in the process. Again, the most important part here when it comes to that utility interaction for us to be able to provide power for your new project is it's engage early, engage early, engage early. So talking a little bit about the specific Penske projects and some of the lessons that both Penske and Southern California Edison learned as we went through those processes. So we'll look at that Chino site. Sean had a really cool picture there, close-up of the equipment. This is a little bit further away picture. But what we were able to do here is help Penske by leveraging an existing transformer at their site that was undersized for the new project. It was originally sized for just their facility. But because the structure the transformer sat on had capacity to take a larger transformer, and the distribution circuit that fed that facility had the additional room to accommodate the extra load, we were able to upgrade that transformer and give them a very simple direct service feed to that new panel. As Sean mentioned, that new EV panel allows them to take advantage of one of our time of use EV rates, and that's essential, rather than trying to leverage an existing switchgear and existing service at a facility. Doing that dedicated service from a transformer really benefits both the customer and the utility for that matter, because it allows us to differentiate that load and understand what part of that load is being used for EV applications. At the site in La Mirada, this is a site where the deployment location did not have any immediate transformation located there. And there was also a desire at this site to be able to give room for future growth. And so here we leveraged an existing pole line nearby the site and installed a new transformer, again with a dedicated EV service. But this site now with that new transformer gives Penske the option, if at a later time they decide to expand this deployment, we sized everything so that we can deploy a larger transformer on that same structure and allow them to expand their service. We move on to the Temecula site, and something that Nate mentioned, and it's a very important piece when you're looking at your EV deployment, is right sizing your equipment. At this location, Penske didn't have the need for the super high powered charging, nor did they have a need for multiple chargers, relatively small location. And so here we helped them with leveraging power from an existing transformer, and they installed just one single 50 kW charger at this location. It gives them that flexibility of charging the vehicles when they're at this location, but it's not one of their main large truck facilities, so they don't have the need to have the really large infrastructure there. And that right sizing then allows them to install much smaller equipment, smaller switchgear, and ultimately smaller charger. And all of that brings the cost of that site down significantly. When we look at the Ontario site, that's kind of, I think Sean said it's sort of like their flagship large site. And this is a really exciting site where they've deployed the battery storage as well as multiple high-powered chargers. At this site, Edison had some grid constraints. It's a very built-out industrial area, and most of our circuits in that area were at or near capacity. And so by early engagement, Penske gave us the input of what they were doing at this facility. We looked at doing some parallel circuit maintenance at in that general area. And we were able to actually cut in some new equipment that made the circuit more robust while we helped Penske with a dedicated line extension to this facility. And that dedicated line extension includes a primary switch that's separate from the rest of the facility infrastructure, such that as they, at some point in the future, decide to expand this location, we can actually switch it away from our other distribution in the area and not have to create an outage that affects multiple customers in that area. It would only affect just this EV portion. So it gives it much greater flexibility for future maintenance. And they also have the flexibility for future growth. The battery storage, when that comes online, is a very exciting new piece with this EV deployment, and will be very exciting to see how that works with their peak shaving and resiliency. Again, I can't stress it enough that early engagement with the utility is what allows these type of projects to be successful. So we're very excited about this deployment. Beyond the Penske projects and the Charge Ready program that we talked about a little earlier, one thing that Southern California Edison is very proud of also is our participation in the West Coast Clean Transit Corridor Initiative. Some of you may have seen the press release that came out yesterday about that. If not, I encourage you to go online to westcoastcleantransit.com and read details about that. But at a high level, this is a conceptual design for charging locations to support EV truck fleets on I-5 and all the nearby corridors, essentially along the entire West Coast. It's identifying 27 sites along the I-5 and 41 on nearby corridors. And all of those sites are roughly 50 miles apart and no more than 1 mile from the freeway. So the idea with this program is through 2025, this consortium of, I believe it's 9 utilities up and down the coast, would support medium and heavy duty trucks with up to 10 350 kW chargers. And as that heavy duty truck market grows and expands, half of those sites would have the capability to be upgraded with additional ports and additional megawatt capacity. It's obviously a very challenging endeavor. The infrastructure costs are astronomical. There are real estate constraints, and then obviously the lead time for construction, whether that be utility upgrades to feed the proposed sites or just the actual physical construction of the sites. But that's a very exciting initiative that Edison's happy to be participating in. So I definitely encourage you to go to that westcoastcleantransit.com and take a look at the press release from yesterday. And then finally, just like I said, join us on this ride. I want to go back to that point I illustrated from the beginning. Engage your utility early. The utilities can help you navigate some of the funding programs. Southern California has our funding program through Charge Ready Transport, but we also have very knowledgeable people on staff that can help with other grants and other fundings. We do offer a lot of other tools, such as an EV fleet fuel calculator, some other exciting pieces like that can really help smooth the journey out for you, and really so you can join us on this ride. So again, thank you very much to Forth and the other panelists for allowing us to participate. We're very excited about this new emerging space.
Great, thanks, Simon. I encourage all the other panelists to join me for the Q&A. I think we have about 15 minutes until 10:07, I believe, for questions and answers. So, and I also encourage the folks that are listening in. I've been seeing that the chat has been very active, which is great. So, and we are compiling some of the questions from the chat. So feel free to put your questions into the chat, and I'll be drawing from those questions in the Q&A. I also want to remind folks, which I forgot to do earlier, that if you are posting on social media, be sure to use the hashtag #RoadmapForth when you're posting. Hope you're all of you who are sophisticated in the social media world are doing this. So I'm going to start with a kind of a selfish question that I saw in the Q&A, because it relates to some investments that the Energy Commission is making in what we're calling our Vehicle Grid Innovation Lab, to allow for some testing of EV charging equipment. And the question was, should there also be a national lab doing the same kind of testing? And this is really, around this question, I think, especially in the heavy duty space, of avoiding what we saw in light duty, which is for DC fast charging, we have 3 different types of connectors, and that actually is a barrier to the market. Just curious about the thoughts from the panel on whether we need something like the Vigil Lab nationally.
Well, I think from a utility perspective, we are very interested in seeing the enforcement of standards through all of the vehicle sectors. Selfishly, from a utility perspective, it allows us to make sure that we're not putting in stranded assets in the field that are no longer useful. But I think more importantly, from a customer perspective, as their fleets grow and they look to use varying OEMs throughout the fleet procurement cycle, they want to be able to have infrastructure that's useful across all those OEMs, not just one manufacturer specific. So I think it's a very important piece that gets support from all levels to keep that that drive towards clear standardization.
Yeah, I'll say a couple things about that as well. Totally agree with Simon. Standardization is key to seeing this industry take off, and not just the standardization of any technology, but technology that will take us 20, 30 years ahead. I spoke a little bit about the Charn organization and the work being done there. And some of the national labs are involved actively in that conversation. Argonne National Labs, NREL is involved, and we'd love for them to have more funding to support even more. That would be great. But yeah, definitely involvement from all parties.
Yeah, I'd agree with both. I think the standardization is going to drive more consistency, drive that price point down, and really get us a little bit more laser focused on pushing this forward.
So one of the questions that has come up is whether anyone is rolling out a total solution with vehicles, infrastructure in an ESCO-like model where the commercial customer only sees savings and no initial cash outlay.
I can touch upon a little bit of what we're doing more on the medium to light duty for now, but we have rolled out a few of the e-canters where we actually put the chargers into our setup and then allow the customer to charge at our facility and utilize the truck based out of that. So that was kind of an all solution for that. I think as we grow into the heavy duty, we're going to probably be again out in the forefront with trying to coach everybody through infrastructure, whether it's on their lot or ours, working with some of the Electrify America and some of the other groups out there to stretch that network. But yeah, I think that is obviously being worked on in the back end. Yes.
I wonder if I could take that with maybe this is for SoCal Edison, which we've seen Dominion Energy fund school buses, and this opportunity for the utilities to own the battery of vehicles and use that as in a second life when the battery is no longer usable for the vehicle. Is SoCal Edison considering that as well, that model?
Yes, it's something that's been discussed internally. I think we're very proud and excited about our Charge Ready suite of programs, both in the light duty and the medium heavy duty space. I think the concept of utility ownership of the battery is certainly something that has potential merit, and it's definitely something that's being discussed internally. I don't know if there's any immediate program that we are looking to launch in that space. I do know some of our peer utilities across the country have some pilot programs looking at that, and I think we're watching those very carefully to see the successes and some of the potential pitfalls and make that evaluation.
I have a question. Where and how are semis anticipated to charge? At distribution centers while they're loading, or at customer sites while unloading? Any sense of what that is going to look like when we're talking about long haul trucks?
Yeah, so initially our focus has been on regional distribution, drayage type applications, and in those cases, the charging would happen behind the fence privately, or if they're leasing through Penske or another company like that, then it could happen at their depot, at the Penske depot, for example. Certainly, as we look into in the future, long haul and trying to extend the technology to meet the needs of long haul applications, that's where the initiative that Simon talked about comes in, and getting chargers out there distributed correctly along the major freeways and interstates to support charging and long haul applications. But you got to get the charge power right as well. No one wants to sit around waiting 3 hours for their vehicle to charge. So we've got to get it down below an hour. If we can, even below that, for that situation to make sense.
And I'll add on to it. I was going to say, I'll add on quickly to what Nate was saying. I think one of the things that we feel very strongly about to advance the success of this space is electrifying those repeatable routes right now. So drayage routes from the ports to our Inland Empire logistics centers, where the routes are very predictable. The vehicles can charge behind the fence with some opportunity charging at locations closer to the port, especially if it's a vehicle that's making maybe a double run on a given cycle.
So what policies on either the state or federal level would best help you accelerate the transition to electric heavy-duty vehicles? And I guess besides funding, because funding I think is a base level need.
Yeah, it's a very good question, and we've thought a lot about this, obviously, at Daimler. You know, maybe the easy solution for a lot is to just throw mandates out there that everyone goes electric, but obviously we have to be very careful about that. As everyone's mentioned multiple times on this panel, the equipment's really expensive, and we don't want to put our customers in a situation where they have to pay for this very expensive equipment. I think funding or policies that support additional research and development to reduce cost, which is being done now, increase of that helps. LCFS credits, I think, have been very, very good. It's not a perfect program, but I think it's a good program, and many aspects of the program we support at Daimler, and think that it's very beneficial to our customers.
Yeah, I think there's a lot of good funding vehicles out there right now, and I think we should certainly encourage those continuing. One of the challenges we've seen from some of our customer base when they try and stack some funding opportunities is that the funding opportunities actually conflict with each other, with conflicting deadlines or conflicting restrictions. And so I think as new programs are rolled out, some flexibility to allow customers to stack those funds to really kickstart deployment and be a good catalyst to getting this into the mainstream.
Mm-hmm.
I think from our side, I was going to say, just to add to that, just streamlining and maybe giving a little bit of preferential treatment to the permitting aspect of this and moving you through the line quicker, or really just trying to standardize what these agencies from county to city are looking for. And maybe, that is pushed down from the federal level down, but it was very inconsistent across 6 locations on the speed of the permitting, the knowledge, the granularity of what they were looking for. So I think there's a lot to go, a lot more that can be done there for the building officials to be a little bit more savvy on this structure.
That actually was going to be my next question. So you go ahead, and then I'll.
Yeah, one more thing relating to local codes. We find sometimes the situation where we want to use charge management software to reduce the grid connection size and the size of transformer and switch gears coming into the site. But local code, even though National Electric Code allows for it, local codes sometimes prevent us from doing that because they require the equipment to be sized to the peak capacity of the equipment on the site. So that can sometimes be an issue.
So are the sticking points on permitting all from a local level from your perspective, or is there anything at the state or federal level that needs fixing?
Well, I can speak from our experience, having built at this point in time more than 100 EV locations, both in the light duty and the medium heavy duty space. There is no consistency, and it is a challenge. And we try and reach out to our various AHJs before we start a project, do good due diligence. But we do find that there are regulations for certain sites that come down from the state. There are other regulations that are ad hoc to individual AHJs, and we try and navigate those as best we can. We're also working with, like with GoBiz, the governor's office, to try and help streamline the California permitting process. But I'm sure that these are going to be similar pitfalls that other states go through as this expands beyond, the initial startup locations in California and the rest of the West Coast.
Can you talk a bit about utility rate design and how that affects the economics of projects?
Yeah, absolutely. You know, we hit on that. Sean hit on it, and I tried to also include that. When we're looking at these EV projects, we definitely recommend looking at the opportunity of a dedicated service for the EV. Southern California Edison has time of use rates, three tiers of time of use rates depending on the usage, the load, and those can be much more attractive for EV charging than the general service rates that a normal facility would have. We also have right now the rates are in the middle of a 5-year demand holiday for EV charging, which is it started in 2019, expires in 2024, and then phases back in over a 5-year period of time. And that demand holiday is really designed to encourage EV adoption and also encourage the users to develop good charging habits. And Nate mentioned managed charging, and EV rate design and managed charging kind of go hand in hand. And learning how to operate the charging, learning how to maximize the efficient time of use, learning how to maximize the charging, again, right sizing that equipment. Not using very large equipment when you've got vehicles that do have long dwell time. If you've got trucks that can sit for 4 hours, maybe you don't need to have 200 kilowatt chargers. And certainly if you've got trucks that sit for 8 hours, you can get away with 50 kilowatt chargers. All of that will reduce your rates and also reduce your infrastructure costs significantly.
I'm curious about how you all are thinking about vehicle to grid. So, not just V1G, but V2G, where you're drawing some juice, shall we say, from the heavy duty battery and sending it back to the grid.
Yeah, so Southern California Edison right now is engaged in a couple of pilot efforts, primarily in the school bus space, because that is the most logical V2G use case scenario. The vehicles sit for a long time. They typically sit, they're only used for a few hours in the morning, a few hours in the evening, and then they've got a lot of dwell time. So we are exploring that. There are a lot of challenges with the technology in that space, a lot of challenges with whether you do stationary inverters or mobile inverters, and that's those are all the different pieces we're looking at through these pilot studies. Certainly, that's a technology we all need to get to, and I think it's a very viable technology, but it's still so nascent that I don't think that it's something we can look at from an immediate deployment scenario. But I think we'll see it as we get through, and I know several other utilities are doing pilot programs also. And as we get through those learnings and develop some standards, again, it goes back to standards. And what are those standards, and how does that, are we doing the tie-in to stationary batteries to support a facility, or are we doing tie-ins back directly to the circuit as load support? There's a lot of different caveats there we have to figure out.
I'll say a few words about that as well. In our Thomas Built bus product, the Julie, that product is vehicle to grid capable. And was it an essential feature for Dominion Energy, for example, and why they were interested in the vehicle. And it does make sense, as Simon said, makes sense in the school bus product. For the Class 8, for the Class 6 products, we're still looking for that strong economic case to include it in those, and how that fits in well with our customer use cases. Don't know that we found that strong use case yet, but it's certainly there for school bus.
And is there a case for battery swapping in the heavy duty space?
Yeah, the idea is very intriguing, and we've looked at it. We're open to the idea. I'll tell you where, from my perspective, the challenge is. A couple of things. First of all, you're taking a very expensive piece of equipment off of your vehicle, and you're leaving it behind to be charged. So utilization on an expensive asset has actually decreased. So there's some challenges there. And also, anytime you're removing or adding equipment to an electric vehicle, I think most people recognize Daimler as, from a safety perspective, extremely conservative. And so there's concerns around getting that absolutely right, so that connection is reliable, it's sealed off to the environment. These are rough applications that our vehicles operate in, and they have to meet very high standards from a safety and quality perspective, and swapping out batteries makes that difficult.
Yeah, I don't think we're talking about forklifts here. I think when you start looking at that, you know, the byproduct of the convenience then is the storage, safely putting these somewhere, having a controlled environment, right? Fire suppression, other things that really come into play with any kind of large thought on kind of a swapping.
Yeah. The other thing I'll say is, the idea or the benefit of swapping out batteries really is a speed thing, the ability to keep your truck on the road longer. I think the idea is in direct competition right now with reduced charging times required. So as batteries improve and can accept larger charge rates, and infrastructure improves to deliver those charge rates, the case for swappable batteries starts to diminish. Maybe it doesn't go away in all applications, but in some it definitely is diminished.
All right, so I think we have time for one last question. I'm curious if you give us a sense of, like, from the time of starting to initiate a project to build out charging infrastructure for a heavy-duty fleet, give us a sense of the timelines. How long, what are the big steps, and how long is it going to take?
I think for us, if we were to do it today, we would say 18 months. Did we do it a lot quicker? We did a few of those under 6 months in the right application. We had the right site, the utility was there, and all of our partners. But to try to say everybody can do that in under 6 months at every site would be really stretching the truth, I think. So.
Yeah,
Yeah,
I agree with. I said 6 to 18 months. I think that's going to, it is a broad spectrum, and we've done large sites in less than that. We've done small sites that take longer than that. So it really case dependent. Ideally, we show up at a depot, and our utility partner is there, and construction partner is there, and you could look for all those things that could extend the timeline out. But it's really a case by case basis.
Yeah, I'll echo that case by case basis situation, and I think that 6 to 18 month timeline is realistic, and it really is site dependent. The other thing that we try and tell our customer base as we're engaging with them is, you don't necessarily have to do all of it overnight. You may have aspirations to put in some pretty significant infrastructure as your fleet transitions over a 10-year period of time. It doesn't mean you need to have all your charging equipment in day one. You can take a phased approach. As long as you do it in an intelligent fashion, you can deploy over time and grow the infrastructure as your fleet grows, and also grow the infrastructure as technology advances, because you may discover that you can get by with less infrastructure as the charge management and charging equipment gets more advanced.
Great. Well, I want to thank my panel, Nate, Sean, and Simon. This has been really informative. And just let folks know the next webinar in the series is going to be Electrifying Transportation Network Companies. There you go. And the roadmap webinar recap is going to be sent out on Friday. So thanks to my fellow panelists, thanks to Jeff and the whole fourth team, and look forward to the rest of the conference.
Thank you.
Thank you, Patty. Thank you, Sean. Thank you, Simon. Been a pleasure.
Thanks, everyone.